Hi guys, this is Saili Jain and welcome to the first part of binary algebra. Since most of us know that all the computers, microprocessors and controllers at a core level only understand binary language, aka the machine language, that is nothing but only ones and zeros. Then I thought that why can't I build a 1-bit computer so that I can understand how a computer does algebraic calculations using only these binary numbers. So in this first part of the video, we'll be making an AND gate. Let's start. So I've used these 4 things to build the AND gate. Starting with the symbol of the AND gate. The symbol of the AND gate consists of 2 inputs and 1 output. Then I've referred to the schematic while building the circuit on the breadboard. And these are the bill of materials required to build an AND gate. The truth table of AND gate which I will be using to check the circuit at the end. And like I said, these 4 things I have used. So these are the set of general tools and components which I've used throughout the process. And I've collected all the materials now. So let's start developing the circuit. And now the power supply circuit is ready on the breadboard. I've used only 7 steps to build this AND gate. And in the first step, I have placed a 10K resistor across the terminal strip 49 to 44. After which I have placed a VCC, I have placed a red wire to connect the VCC across the bus strip to the terminal strip 45. And now I am going to place the first transistor of the circuit in a way that the VCC is connected to the collector. Now I have placed a green wire which in turn will be used to connect the first transistor to second transistor. Now placing the second transistor. After this I have placed the 10K resistor which is connected to the base of the second transistor across the terminal strip 38 to 33. And now I have placed a 1K resistor across the ground bus strip and terminal strip 37, and our AND gate circuit is complete. Now in the next 7 steps, I will be adding the input switches and LED for testing the circuit. So starting with the input switches, placing the first input tactile switch across the terminal strip 41 to 48 and placing a red wire to connect the switch to VCC to give it an logic high. And now placing the second switch or the second input across the terminal strips 30 to 33 and again connecting it to the logic high using the red wire which I have placed across the bus strip to the terminal strip 31. And now I'll be placing in the LED. So I have connected this blue wire to the emitter or the output of the circuit. The emitter of the transistor. And I have placed the LED over here. And in the circuit diagram, I have first placed a resistor. But in the circuit, I have first placed the LED. We can do it either way around. And like I said, this is the last step, placing the 330 ohms resistor, whose second leg is grounded. And this is a completed AND gate circuit. Yay! So we are done. We should start testing it now. And remember the truth table of the AND gate. So we will be using the combinations given in this truth table to check whether a circuit is complete and correct. And the LED will be only on when both of the inputs are on. So let's check it out. The circuit is powered up now. The 2 tactile switches placed over here represent input 1 and input 2. So now in the first case, the both switches are not pressed, which is nothing but 0 and 0. So the output is also 0 because the LED is not glowing. In the second condition, I am pressing the second switch, that is nothing but input 2. So it is 0 1, and the output is also 0 because the LED is also not glowing. After that, I'm pressing the first switch, that is nothing but 1 0, and the output is still 0. Only in the last case, in which I'm pressing both the switches, that is nothing but 1 and 1, the output is 1.